Hello. We had learned the first 20 elements of modern periodic table. Now in today's class, we will be discussing about the electronic configuration of these elements. As we go from left to right, what is the electronic configuration? As we go from top to bottom, how is the electronic configuration? Based on this electronic configuration, we will be learning more about gradation and similarity. Similarity means how the elements are similar in, suppose if I am talking about elements of group 1, it will be little similar to elements of group 2, but elements of group 1 will have lot of difference between the elements of group 18. Okay, so how are they different? On what basis? What is the fundamental thing which causes this difference? It is the electronic distribution. That is the electronic configuration. So electronic configuration describes or decides the properties of the elements. We'll be discussing more on this topic in today's class. So let's begin. First, we will write down the 20 elements of periodic table. Then we will talk about the electronic configuration. So please write down the first 20 elements. So hydrogen and helium, lithium, sodium, potassium, beryllium, magnesium, calcium. Then 3 to 12, we are leaving them. Boron, aluminium, CSI, NPOS, FCl. Below helium, neon and argon. Okay. So this I will keep it here this way for our reference. As we know, atomic number of hydrogen 1 and helium is 2. So similarly 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Hydrogen, lithium, sodium and potassium, they all are coming in group 1. Group 1 elements are also called as alkali metals. Beryllium, magnesium, calcium is coming under group 2. They are called as alkaline earth metals. Then 3 to 12 we are leaving them. Let us talk about 13. Group 13. This carbon will belong to group 14. 15th group we have nitrogen and phosphorus. 16th group we have oxygen and sulfur. 17th group we have fluorine and chlorine. And 18 group we have helium, neon, argon. This 18 group is also called as zero group because they are noble gases or inert gas. They don't participate in any chemical reactions. Okay. Now, they don't participate. They are very inert. They are noble gases. Like noble means belonging to some royal family. No, they don't talk much. Okay. Same way, these elements also, they don't react much. So we will talk about the other elements. Let's start. First, let us talk about hydrogen. Group wise, let us discuss first. Then we'll go period wise. Okay. So if you consider the elements of first group, let us see the electronic configuration. Hydrogen, I will write 1. Lithium, atomic number is 3. No? So the electronic configuration will be 2, 1. For sodium, the electronic configuration, the atomic number is 11. How will you distribute the electrons? 2, second shell can hold only 8 and third shell 1. So 2 plus 8, 10, 10 plus 1, 11. This total and atomic number should be same, right? This is called as the electronic configuration. We all know shells KLM. Okay, so same way we distributed the electrons. Now let us talk about potassium. Potassium atomic number is 19. So as soon as you get your answer sheet, no, in one page you can write the elements in serial order. Or first 20 elements you write and keep, so that any question you can attempt. Okay. So once this is ready, we have potassium's atomic number 19. Let us show the electronic configuration. How will it be? 2, 8 means 2 plus 8, 10. Here we have, then again the third shell will hold 8 electrons. 10 plus 8, 18 and 1. This is for potassium. this is hydrogen, this is lithium, this is sodium, and this is potassium. Now let us learn the properties. Elements in the first group. Okay, we wrote the electronic configuration of elements in the first group. As you see, the valence electrons. What are valence electrons? The number of electrons present in the outermost shell. The number of electrons present in the outermost shell is called as valence electrons. Now see the number of electrons present in the outermost shell. For all the elements it is 1. If the number of electrons in the outermost shell is 1, if the valence electron is 1, that means that the element belongs to group 1. You have to do the electronic configuration. If there is only one electron in the outermost orbit, or if the valence electron is 1, that means the element belongs to group 1. Okay. Now let us check the second group. Second is of group 2, beryllium, magnesium and calcium. Beryllium atomic number 4, magnesium will be 12 and calcium will be 20. Let us see the electronic configuration. For beryllium it will be 2, 2, 2 plus 2, 4. Correct? Magnesium atomic number is 12. So electronic configuration will be 2, 8, 2. For calcium it will be 2, 8, 10. Again 8 and then 2. Correct, no? 10 plus 10, 20. So now compare the valence electrons. How many valence electrons are there for all the elements belonging to second group? There are only 2 valence electrons. So if the valence electron is 2, then the element will belong to group 2. If the valence electron is 2, then the element belongs to group 2. Valence electron is 1, element belong to group 1. Now let us check about 13th one. 13th group, boron is 5. So what will be the electronic configuration? 2, 3, right? For aluminium, if aluminium atomic number is 13. 13. So 2, 8, 3. Are you getting? So here the group is 13. The valence electron is 3. You have to see the units place. Okay, so group number 13, units place is 3. Number of valence electron is also 3. Group number 14, carbon. Carbon atomic number is 6. How will you write the electronic configuration? 2, 4. 2 plus 4 is 6. So group number is 14. Valence electron is 4. Silicon. Silicon atomic number is 14. 2, 8, 4. Again, valence electron is 4. Number of valence electrons 4. So it belongs to group 14. Now let us check group 17. Similarly, let us check group 17. Group 17, the element is fluorine. Fluorine atomic number will be, if this is 6, 7, 8, 9. No? Fluorine's atomic number is 9. So the electronic configuration of fluorine, for fluorine, atomic number is 9. So the electronic configuration will be 2, 7. 2 plus 7, 9. Valence electron is 7. So you have to add 10. So you can decide to which group it belongs. So if the valence electron is 7, 7 plus 10, 17. So fluorine belongs to group 17. Like that, objective question can come. Suppose we have an element, we don't know which is that element. The electronic configuration they have given is 2, 8, 6. And they are asking this element you have to identify to which group and period this element lies. First we will decide to which group this element lies. So you will look at the last shell. The number of valence electron is 6. If it is 1 or 2, if the valence electron is 1, then it belongs to group 1. If the valence electron is 2, it belongs to group 2. But if the valence electron is more than that, okay, 3, 4, 5, 6 and all, you will add 10 to that number. So here the valence electron is 6. 6 plus 10, 6 plus 10 is 16. That means this element belongs to group 16. It belongs to group 16. Here, how many, what is the atomic number? The atomic number will be 2 plus 8, 10. 16. Okay, so atomic number is 16. So which is that element? Atomic number is 16 means which is that element? Silicon is 14, phosphorus is 15, sulfur is 16. So this element we are talking about is about sulfur. You can expect such questions. They will give you the electronic configuration. They will ask you the group number. If I give you 2, 8, 1. So here the valence electron is 1. If it is 1, group 1. If the valence electron is 2, group 2. If the valence electron is 2, 8, 7. Suppose valence electron is 7. For numbers apart from 1 and 2, you will add 10. So plus 10. 7 plus 10 is 17. So this element belongs to group 17. Clear? So 2 plus 8, 10. 10 plus 7, 17. Which is this element? This element is nothing but our chlorine. Right? So this way you can say to which group the element belongs to. Now let us talk about elements as we go in period. So first period is hydrogen and helium. Hydrogen and helium, atomic number is 1, so electronic configuration of hydrogen 1 and helium 2. Next, second period. Second period, the elements are lithium. Okay, so I'll show the electronic configuration. Atomic number is 3, so electronic configuration will be 2, 1. Then we have beryllium. Atomic number is 4. So the electronic configuration will be 2, 2. Then we have boron. Atomic number is 5. Electronic configuration 2, 3. Carbon 6. 2, 4. Nitrogen 7. Atomic number. So 2, 5. Oxygen 8, atomic number 2, 6. Fluorine 9, atomic number 2, 7. And we have neon 10, atomic number. So we have 2, 8. Now just to look at the electronic configuration, as you move from left to right, you can see that the number of valence electron is increasing by 1. The number of valence electron here 1, 2, 3, 4, 5, 6, 7 and 8. Valence electron is increasing by 1. Now let us talk about the number of shells. For the second period, you had 2 shells, K shell and L shell. For all the elements you have 2 shells. So if you have only 2 shells in the electronic configuration, then the element belongs to period 2. If you have only 1 shell like hydrogen and helium, then the element belongs to period 1. So if you have 3 shells, then the element belongs to period 3. Let us check about the third period now. Third period, which all elements are there, starting with sodium. Sodium atomic number 11. Now you should write the electronic configuration first. 2, 8, 1. 3 shells you got. So 3 shells means the element is belonging to period 3. Similarly, magnesium 12. No? So 2, 8, 2. Again 3 shells. And for every shell, the valence electron is increasing by 1. Check for aluminium 2, 8, 3, 2, 8, 4, 2, 8, 5, 2, 8, 6, 2, 8, 7, 2, 8, 8. Similarly, as you see, so from the number of shells you can decide the period number. From the valence electron you can decide the group number. Is it easy? This way we saw that elements belonging to the same group, they are similar as well as they show gradation. What is gradation? Gradation means for every element that is following, there is something new to add. There is a series which they follow. You have the numbers belonging to arithmetic progression where they follow a certain pattern, no? Same way, this elements belonging to same group, they show similarity as well as gradation. Okay, when we compare the properties of elements in a period and in a group, we see that there is certain regularity which they follow. So there is a regularity in their variation. Now the way they vary, but they vary in a regular pattern. They follow a regular pattern and then they vary. This property is called as periodic trends in modern periodic table. The periodic trend that we'll be learning is about the valency. Now valency, very important term. You know about valency. Valency of an element can be determined by the number of valence electrons present in the outermost shell. Suppose if you have, if an element has 2, 7, if this is the electronic configuration, there are 7 valence electrons in the outermost shell. Every element is trying to attain a stable form. So 7 means it needs one more electron to complete its octet. So it will try to accept that one electron. So the number of electrons which is accepted, which is donated or which is shared is called as the valency. So valency depends upon the number of valence electrons present in the outermost shell. So here the valence electron is 7, but valency will be 1 because it needs one electron to complete its octet. Another example. Here, if I give the example of this electronic configuration, that is I am talking about carbon. 2, 4 is 6, no? 2 plus 4 is 6, so it belongs to element carbon. Here it has 4. It can either donate 4 or either take 4. If it donates 4, again it is stable, it will complete its duplet. If it takes 4, octet. So here the valency is 4. Number of valence electrons is also 4. Now let me talk about another one, simple 2, 6. That is, here I am talking about valence electron 6. Now 6 means it needs 2 more electrons to complete its octet. So valency will be 2. Whereas valence electrons, the number of valence electrons is 6. Now let's learn the periodic trend valency with respect to these elements. Now I have taken the example of first group elements and the elements belonging to group 17. Let us check about the property valency with respect to these elements. In the group 1, hydrogen 1, so here electronic configuration 1, valency is also 1 or valence electron is 1. For lithium it will be 2, 1. For sodium it will be 2, 8, 1. And for potassium it will be 2, 8, 1. Correct, no? Now if you see the valence electron, what about the valence electron? 1, 1, 1 and 1. Elements belonging to same group, that is group number 1, they all have the valence electron as 1. That is why elements belonging to same group have same valency. Elements belonging to same group, why do they have the valency also same? Because valency depends upon the number of valence electrons. All the elements belonging to same group have same number of valence electrons. So if the valence electrons is same, valency will also be the same for all the elements as you go down the group. Let us check with another group, 17 group elements I have written, fluorine and chlorine. For fluorine the atomic number is 17, no? And for fluorine it is 9. Correct, right? Atomic number is 9 for fluorine. Let us see the electronic configuration, 2, 7, and here it will be 2, 8, 7. Depending upon 2 shells. Now here 2 shells, so this element is belonging to period 2. But which group? I told you to add 10, no? So 7 plus 10, 17. This also 7 plus 10, 17. Both are belonging to group 17. Now let us talk about the valency or valence electron. Here the number of valence electrons for both the elements is 7. So the valency will also be the same. Valency will be 1. No, here 7 means it needs 1 electron. So valency is 7. That they will not ask. They will ask you why the valency is same as for the elements in the same group. Because the number of valence electrons is same, so the valency also will be the same. But as we go from one element to the other element, as we go from left to right, is the valency same? No. The number of valence electron increases one at a time. One by one it increases. Okay, so that's it for today's class. What did we learn? We saw the electronic configuration of elements in a group for a period, and we also learnt about the first periodic trend that you observe, that is about valency. In the next class, we will be talking about two more examples of periodic trends. Till then, be thorough with this part. Take care. See you.